Okay guys, I'm going to broadcast here the solutions to problems 9, 10, and 11 in your learning packets. These are electroplating problems. In problem number 9, the first step is to get the oxidation number. So we're dealing with Zn in ZnCl3. So that's going to be x plus 3 times minus 1 equals 0. X equals plus 3. So that's going to be Zn3 plus 3 moles of electrons every time you want to reduce it down to Zn solid. The moles of electrons needed is 3. What we have in this problem is going to be, we have 40 minutes. Okay, that's what we're starting with. So you're starting with 40 minutes. And I believe what they're looking for is the mass of Zn that we can plate. Yes, grams of Zn. So that's how many grams of Zn. Let's go down here and put in our conversion factors. We know that Faraday's constant is 96,500 coulombs for every 1 mole of electron. It's totally okay to abbreviate coulombs as C. What is the current in this problem? 1.50 amps is the current. So I'm going to break that out as coulombs per second. My mole ratio is for every 1 mole of Zn, that requires 3 moles of electrons. And the molar mass of Zn, if you look on the periodic table, it's got 30 protons. So that's 65.39 grams of Zn for every 1 mole of Zn. So let's start off. We got 40 minutes, and we want to know how many grams of Zn. So in every 1 minute, there's 60 seconds. And in every 1 second, there's 1.50 coulombs. And in every 96,500 coulombs, we have 1 mole of electrons. And there are 3 moles of electrons per every 1 mole of Zn. And per every 1 mole of Zn, it is 65.39 grams. Ooh. Yeah. So we're going to do this calculation, and we're going to take 40 times 60 times 1.5 divided by 96500 divided by 3 times 65.39, and that equals 0.81 grams. Now, if I'm off here, I apologize. I'm using a serious ghetto calculator right now. But if your setup is like mine, you guys are fine. Okay, 10. Notice I pulled away the scaffold here. I pulled it away. So let's try and just do this problem anyway using the same structure. I'm dealing with Mn and KMnO4. So I know that I have 1K. That's going to be plus 1 plus X plus 4 times minus 2 equals 0. That's going to make X plus 7. So our reduction half reaction is 7 electrons are going to be required to reduce Mn to 0. In step 3, N equals 3 moles of electrons. Let's set up our factors. We know that Faraday's factor is 96,500 coulombs for every mole of electron. We know that the current is 2 amps, so 2 coulombs in every second. We know that the mole ratio is 7 to 1. So for every 1 mole of Mn, 7 moles of electrons. And we know the molar mass of manganese is 54.94 grams of Mn per every 1 mole of Mn. So what do we have in this problem? We want to know how many minutes. So minutes it would take to plate out 25 grams. So working backwards here. Okay, so let's work backwards, no problem. We know that there are 54.94 grams of Mn for every 1 mole of Mn. We know that there are, for every 1 mole of Mn, 7 moles of electrons. And we know that in every 1 mole of electrons, 96,500 coulombs. We know that there's 2 coulombs for every 1 second. And we know that there are 60 seconds in every 1 minute. So let's do out this calculation. We get 25. You're going to divide that by 54.94. And then you're going to multiply that by 7. You're going to multiply that by 96500. You're going to divide that by 2. And you're going to divide that by 60. And you get 2,561 minutes. A ridiculous answer because I made up this question off the top of my head. Sorry about that. Alright, number 11. I'm going to try and jump right, take some shortcuts here in this one. Actually, no, I'm not. Let's go through it normally. You're going to have x plus 1 times minus 1 equals 0. X equals plus 1. So Ag is going to be plus 1 plus 1 electron goes to Ag0. N is going to be equal to 1 mole of electron. So for my factors here, I know C last problem, and I know in this one I'm going to have 1.20 coulombs per every second. I know that I have 1 mole of Ag per every 1 mole of electrons, and I know that 1 mole, where the heck is Silva? 1 mole of Ag is I have 107.87 grams of Ag per every 1 mole of Ag. So they're looking for hours. So hours and 2 moles grams. Why don't you guys just say 2 grams? So 2 grams. I know that there is 107.8 grams for every 1 mole of Ag. Apologies, I'm moving fast here, but I got my 10-minute limit here for YouTube. For every 1 mole of Ag, it's 1 mole of electrons. For every 1 mole of electrons, 96,500 coulombs. 1.20 coulombs, 1 second. And there are 3,600 seconds in every 1 hour. Let's do this out. You should have 2 divided by 107.8 equals that, times 96500 equals that, divided by 1.2 equals that, divided by 3600 equals that. So you should get 0.41 hours. Again, this calculator's ghetto. That might not be correct, but this process is what I'd like you to have down. I'm sorry for rushing through that, guys, but that should give you exactly what you need to know for all electroplating problems for the AP test. Take care. Bye.